Welcome to question number 6. Here you can see a sketch of the curve with equation y equals x minus 1 times the natural log of x, where x is greater than 0. And in part A, we're asked to complete the table with the values of y corresponding to x equals 1.5 and x equals 2.5. Okay, so you might like to pause the video and write in your answers, come back when ready and check to see if you've got them right. Okay, welcome back, see how you got on. Now all we've got to do is just substitute x is 1.5 into the equation up here to get what y is. Now looking at these answers that we were given, they're not worked out as decimals, so it just seems that quite happy then to accept us just putting the 1.5 in. So 1.5 take away 1 is 0.5 multiplied by the natural log of x, and x is 1.5, so that would be 1.5. And when we come on to x equaling 2.5, we have 2.5 take away 1, which is 1.5. and that's multiplied by the natural log of x, and x is 2.5. Okay, so if you got that, it's worth 1 mark. So there we have 1 mark. Okay, now we move on to part B. And in part B, we have 2 parts to this question. The first part, we're told that we're given that I is equal to the integral from 1 to 3 of the graph above, which is x minus 1 multiplied by the natural log of x integrated with respect to x. And we're asked to use the trapezium rule with values of y at x equals 1, 2 and 3 to find an approximate value for I to 4 significant figures. So you've got to use the trapezium rule with the values of x, 1, 2 and 3, and give your answer to 4 significant figures. Okay, so leave you to do that. Just pause the video and come back as usual when ready to check your answer. Okay, welcome back. Let's see how you got on with this. Okay, using the trapezium rule, and by the way, if you do struggle with the trapezium rule, you might like to look at our videos on the forum for the trapezium rule. Okay, so assuming you know that, I is going to be approximately equal to, now it's half the width of each interval, and because we're using the values of x as 1, 2 and 3, the interval between these is a gap of 1. So the interval, or width of each strip if you like, is 1, and that's going to be divided by 2. It's always half the width of an interval. Then it's the first height, and the first height will be the first y value, which will be 0. I'll put that in just to show that I've used that. Then it's plus 2 times the sum of the middle heights. Now the only middle height or middle value that we've got is the one associated with x equaling 2, which will be this y value, the natural log of 2. So it'll be 2 times the natural log of 2. There's no other middle heights, okay, the one here being the 0 being one of the end heights, and 2 natural log of 3 being the other end height. So we finish that off by closing that bracket, and then it's plus the last height, which is 2 natural log of 3. So I'll write that in as 2 natural log of 3. Close the bracket off, and so all we need to do now is just work this out on the calculator, and if you work it out you should get 1.79175, and so on. So I'll just write 3 dots there to illustrate and so on. And because we've got to give it to 4 significant figures, this will be equal to 1.792. And I'll just write in that that's 4 significant figures, 4 SF. Okay, so that's the end of B part 1, and we move on to B part 2. Let's just scroll up to there. So B part 2, we've got to do a similar thing again, only this time using the trapezium rule we've got to estimate I using all the values of x in the table. Okay, and again give our approximation to 4 significant figures. Okay, so you may pause the video again and have a go, see how you get on. Come back when ready. Okay, welcome back, and let's see how you got on then with this approximation. So again, it will be I, and it will be approximately equal to, and it is the width of each strip or interval, and in this case, because we're using all the values of x, we can see that going from 1 to 1.5, 1.5 to 2 and so on, that it's going up in intervals of a half. So put the interval down, that's 0.5, and divide that by 2, half the width of an interval, and then put a big square bracket up here, and then it is the first height, which is 0, plus 2 times the sum of all the middle heights. So that's this one, and this one. Okay, so I'll write those in. So the first one is 0.5 times the natural log of 1.5, then it's plus the second value here, which is natural log of 2, plus, and then this value here, 1.5 times the natural log of 2.5. So that's twice the sum of all the middle heights, and then plus always the last height, which in this case is 2 times the natural log of 3. 2 times natural log of 3. So that's the end of the sum, so I'll just close that there. And again, just a case of getting on the calculator and working this out. And if you do, you should get 1.6844 and so on. So put 3 dots there, and again we have to give this to 4 significant figures, so it is 1.684 to 4 significant figures. Okay, so that brings us to the end of B part 2, and if you did that one according to the paper, you would have got yourself 5 marks, so well done if you got that.